All right, so let's do this. Acids and bases. So we're talking about the pH. What pH would you have for an acid? Do you remember?
7.
So 7 is neutral. So if it's less than 7, it's an acid. If it's greater than 7, it's a base. So I'm just using those symbols, although it almost looks like a bunch of 7s. So I guess technically for a base, you could say it's between 7 and 14, but it can't actually be 7 because that'd be neutral. So I'll just say greater than 7. It's fine. Just know the end of the scale is 14. I think you guys know that. And so we're going to have that little tidbit to do the next piece. So we're going to look at how logarithms are related to pH. So the pH is an exponential system, meaning as you go up each number on the pH scale, it actually multiplies by 10. So when we want to go backwards, you do a log, and they have a negative sign in the beginning so that all of your pHs will come out positive. So it's negative log of the hydronium ion concentration in moles per liter. So this is just going to be some number in scientific notation that we use. And there's an example down here. Find the pH of a substance whose hydronium ion concentration is 2.5 times 10 to the negative 4th moles per liter. So you literally just do negative log of 2.5 times 10 to the negative 4th. And you just type that into your calculator. It'll give you the open parentheses. You do the closed parentheses. And we'll round it off to say a tenth. So if you type that in, it's going to come out 3.6. If you forget the negative on there, it'll just say negative 3.6, and you can just change it to positive because the scale goes from 0 to 14. There's no negatives. So that's how you can get pH. And then it doesn't ask us to classify, but we could. Since that's less than 7, this would be an acid. All right. So the next question says, if the hydronium concentration of a substance is 5.01 times 10 to the negative 9th, classify the substance as an acid, base, or neither. So they don't really care about the pH so much as that we figure out what kind of a substance it is. So just do negative log of 5.01 times 10 to the negative 9th. Just put all that in the parentheses when you type it into your scientific calculator. And that will come out to be a pH of about 8.3. So it is a little bit bigger than 7. So it's a base. Yay. Now, what gets more interesting is when we go backwards and they give you the pH and they want the hydronium concentration in moles per liter. But we know how to solve these equations, so I'll just show you. So it says find the hydronium ion concentration of a substance and its pH is 9.8. So the formula is negative log of what we're looking for. So I'm going to call it negative log of x and set it equal to 9.8. Before I can rearrange anything to solve this, I want to get rid of the negative. So basically just divide both sides by negative 1. It'll just change the sign. So I'll have log x equals negative 9.8. And this is one of the ones that we could solve very simply by putting it into exponential form. Remember, if it just says log, that is a common log, which is base 10. So you're just going to have 10 to the negative 9.8. And I know it's weird because that already looks like scientific notation, but if you type it in, it's going to tell you it's about 1.58 times 10 to the negative 10th. And this is what they actually will have on the answer key. So it's the same number, just written with scientific notation. You have a number times the power of 10 instead of just a power of 10. And that's what they're looking for. And there's one more of these. So just one more time. Negative log of x, because they're giving us the pH is 4.5. Just make it equal to 4.5. So divide by negative 1. That'll give you log of x is negative 4.5. And then because this is a common log, that means this is base 10. So you can just put it in exponential form. We will type in 10 to the negative 4.5 power. And on this one, my calculator did not give me scientific notation. It said 0.0000316. You could give it in scientific notation, but this one was actually a large enough number that it would do the decimals. So either way, this would be 3.16 times 10 to the negative 5th. Yeah, it's no big deal. So that's pH. Pretty straightforward. Just using some common logs. You have to be able to go back and forth between the logs and the exponential, but not a big deal. Okay, now we're going to look at decibels, and it depends on which textbook you're looking at, how they do this decibel formula. Ideally, in some books, they will give you an intensity of the sound measured, and then you compare it to the threshold sound. Threshold sound is the lowest decibel sound that the human ear can hear, ideally, if you don't have any hearing damage. And so what they do is they take a sound and make a ratio out of it and divide whatever you're hearing by that threshold sound, take the log of it, and take it times 10. So in some books, they'll actually give you both of these numbers, and you'd have to put them in. The textbook that I was using when I first put together the slideshow that this is coming from made it a little bit easier. They went ahead and gave you what that ratio was. So let me show you how that was set up. So it says find the decibel rating of a sound with an intensity that is 10,000 times the threshold sound. So basically that means they've already divided the sound by the threshold sound. Usually there's some really crazy looking scientific notation type numbers. And so they're just telling us it's 10,000 times louder than what the human ear is capable of hearing at the low end. So the formula for decibels is basically, I think dB is decibels. You're just going to do 10 times log of 10,000. And log of 10,000, because it's base 10, is just going to be 4, because 10 to the 4th is 10,000. So this is 10 times 4. So I can do that one without even using my calculator, or you could totally type it in. You don't need the little 10 there, and you're going to end up with 40 decibels.
That was a hard one.
So basically, you're just typing in 10 times log of 10,000, and you get 40 decibels. And you have to realize, because they're using a log, this is also an exponential system. If you go up 1 decibel, you're actually increasing the intensity of sound by 10. And so that's why you go backwards. They use logs, and anyway, it's all kind of interesting.
So the next one's 1,000.
So the next one says how many times more intense is a sound that is 30 decibels than threshold sound. So basically you have 30 equals 10 times log of x. And so you're just putting this in and trying to figure out that intensity. And I think you had it, but we'll just go through the steps. So you want to solve for the log part first. So divide both sides by 10. You'll get 3 equals log of x. And since this is a common log, it is base 10. So to solve it, you would basically have x be 10 to the 3rd power, which is 10 times 10 times 10, which is 1,000. So if you have something that is 30 decibels louder, so do any of you guys have headphones that tell you the decibels? No? Used to be a thing. If you go up 30 decibels, which doesn't seem like a lot, you're actually increasing the sound going into your ears by 1,000 times. So it's something to think about with hearing loss, with all the noise canceling, really intense beats and things that are out there. They're showing a lot of hearing damage just from the intensity. And even if you have a fancy one that tells you, you're like, I'm just increasing it 10 decibels. Well, that's actually a lot more than you think. So anyway, interesting. So the last part of this, it's still kind of science, but it's more like science of the brain. It's a formula for learning curve. We've all heard about the learning curve, and you may not realize there's actually a mathematical scientific function that goes with that. There is a function or a basic type of function where we learn how long it's going to take for somebody to get something down. You know, they'll say, oh, that learning curve is steep. What that actually would mean is that you're learning fast, but people don't use that phrase very well. But this is the formula. So U of N is the hours of labor for, so this is a learning curve. This would be used by an employer, probably in a factory, like if you were building engines in an auto factory, if you were building cell phones in a cell phone factory, whatever you are doing, this is thinking about more of a manual labor, and you're in charge and you're trying to maximize your manpower. So this is the hours of labor for the nth product. So this would be, if this is 5, that'd be how many hours it takes to make 5. If it's 10, it's the hours it takes to make 10. K is the hours of labor it took to make the first product. The idea is the very first time you're making something, you're going to be slow. And then as you get better, it's going to get faster. This also applies to learning skills, like you could think of athletics, you could think of doing a math problem. This applies to lots of things. It just has to do with learning in the brain. And then N is the number of products made. And B, you have to calculate first. R is the learning rate. And it's always log of 2 just because it's part of a formula. Dividing by log of 2 is used a lot as an estimation for things. And there's a big proof that goes with this, but if you were using this on the job as like a foreman, you basically would have to know how to use the formula. So, interesting story problems. The Carter Truck Company produces diesel engines for trucks. Find the number of hours required to build the 45th engine. So we're going to build U45. So that would be the hours it takes to do 45. Assuming that the learning curve is 75%, so that's R, and it took 48,000 hours to build the first one. So you're not thinking about necessarily one person. This is man hours, and so you've got a team. So maybe there's 48 people, and it took 1,000 hours for 48 people to do it. They consider that 48,000. So this might be a prototype. So this might be a prototype. And the prototype takes years to develop. After that, maybe not so much. Maybe this is something custom. I don't know. So the original time it took to make the first is 48,000 hours. We're trying to make the 45th, so you put 45 in as the base. And then the exponent is log of 75%, so 0.75 over log of 2. So this is a little interesting to put into the calculator. You basically have to use some parentheses on that power. So let me go through that with you. So you're going to do 48,000 times 45. And then when you go to do your power, I would do parentheses log of 0.75 divided by log of 2. You got to make sure you close all of those parentheses down. And then you find out that the 45th one is only going to take 9,800, and if we round it off, about 88 hours. You just round that up to the nearest hour.
That's still over a year.
45 engines isn't very much. So when you first come up with a prototype, the prototype takes years. And then you're going to spend time with an assembly line perfecting how the assembly line is going to work. Most new products take a very long time before they hit the market, unless it's something very similar to something that's already been done.
1.12 years.
So it takes a while. So this may not be typical for something that's very similar to what your crews made before. It would have to be something really new, but basically I just want you guys to know how to use the formula. This came out of a book. I did not write that one. Here's another one. The Lewis Engine Works produces gasoline engines for lawnmowers, much smaller. Find the number of hours required to build the 30th engine. So that means N is 30. Assuming that the learning rate is 82%, so that's R. And it took 510 hours to build the first one, so that's K. So you'd set up So 510 hours to make the first one. We're on the 30th one. And then you have log of 0.82 for the 82% over log of 2. And it does come out to be, if we round to the nearest hour, about 193 hours. And that's man hours. So, I mean, if you have a team of 20 people, that's only 10 hours. Maybe this is more realistic for something that you're just training a new team, but they've got all the kinks worked out. I don't know.
Yeah, I think